next week. Okay, coming next week. So we have two revision sessions planned. Uh, in one session, we will just summarize week 1 and 2 and solve problems. And in another session, we will do week 3 and 4 along with mock. So we'll also release mock for quiz one. And after you attempt mock for quiz one, you will understand the level of quiz one. How will the level be? Okay, so we'll do all these things in the revision sessions. But as of now, let's focus on uh, maybe how to. So let's name this session. Okay, so how to solve a problem in exams.
Sir,
Hmm.
actually, I have a general doubt.
Hmm.
I didn't attended the last 6 to 7 classes because my mother was admitted to hospital and I had
Okay.
to be with her. So will this affect my grades? Uh,
It's not about grades, but it's good. It's good to submit that form. We have circulated a absentee form. So just
Actually, I
fill that.
didn't. No, I didn't fill the form, but I mailed the support team that I'll not be able to attend the classes for 6 to 7 days.
You mailed, na?
Yes, sir, I
Also,
mailed.
it's good to submit the form. Also, just submit the form in the remarks or
Okay.
the comments. You just
Okay.
state this reason.
Okay, sir. I'll submit
But
if the date is.
yeah, I hope your mom is okay now, and it's
Yes, sir. You know,
if
she's
you
fine
can,
now. She's
yeah.
Yeah, she's
Then
fine.
from now on, just try to attend most of the sessions. Okay, it will not
Yes,
be.
sir. I'll attend every class now.
Sure. All
Okay,
right.
thank you so much.
Subhash. Yeah, yeah. Subhash, you can
Yes,
start.
sir.
We are live
Yes, sir.
now. Yeah.
Okay. Thank you. Mm, I guess my screen is visible.
Yes.
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 Okay. Week four, professor mainly deals about limits. Uh, okay. So what is a limit? Basically, where do we use limits mostly? Can anyone just uh, unmute and say, see, I'm asking in the sense because, see, for example, if they say that limit extends to some 3 at f of x, why do we have to really use the limits when we can directly substitute the number 3 in the function f of x? Okay, it is being live streamed, but no problem, you may answer. Or else, if you don't answer, I will just try explaining. So, basically, why do we use limits? Because a function might not be defined at all the input values. For instance, a function might have some undetermined forms. So, what are undetermined forms? It's like 0 by 0, infinity by infinity, or 0 into infinity. So, of these forms, if it has these forms at this particular inputs, at that input, we can say that the function doesn't exist. But uh, so we use limits to find the value of the function in some of such cases, not all the cases, but in some of the such cases, we can find the value of the function at such undeterministic inputs. So that's the reason we use in limits. Okay, so I think you are all familiar with the various ways to compute a limit.
Yes.
So, for example, if you have two polynomials like f of x by g of x and limit extends to infinity, there are various ways to, for example, if this is taking some of the undeterministic form, there are various ways to compute it. So, a few ways are like if there are some common roots, or else let's say that instead of extends to infinity, uh, let's think that extends to k. and also it is given that f of k is equals to some 0 or infinity, and g of k is equals to some infinity. Finally, I'm trying to say that f of k by g of k takes up some of the undeterministic form. So various ways to compute this is, we can either find if, for example, if both of these equations have a root at k, you just eliminate that common factor term, and then you find the value of the rest of the expression at x is equals to k. Or else, for example, if you are trying to say x tends to infinity or x tends to 0, you can also apply the L'Hospital rule. You basically find the determinant of numerator and denominator. Okay, maybe it is determinants are not discussed as part of the course. I think you are all familiar with
Sorry for intermit,
differential.
but I
Yeah,
think L hospital's rule is mainly satisfy the equation when the equation have differentiable.
yeah, yeah, yeah. Both your numerator and denominator should be differentiable.
Yeah.
I'm trying to state various ways.
In case it doesn't differentiable, so
Then see, that's what I tried to say. No? There are various ways to find the limits. First of all, if your left hand limit and right hand limit are equal, then only we can say that the limit exists. And once you confirm that the limit is exist, you come up with various ways. If it is in this rational form, and also if both the numerator and denominator are differentiable, then and also if this whole expression is taking up an undeterministic form at x is equals to k, then you can use L'Hospital rule. Or as I said, right, you can eliminate the common factor between numerator and denominator. That's one of the way. For example, if x is tending to infinity, you can take out the highest power term in both numerator and denominator. There are various ways. So the point I'm trying to conclude is, once you are familiar with various ways, now let's see a few applications where we use them. So before getting started, just a quick recap. I mean, I think you would have already studied about these concepts in your ESTC. So you know a resistor, right? And a capacitor.
Yeah.
So okay, so let's think that this resistor have resistance R and this capacitor have capacitance C. So what will be the behavior of this resistor when we attach an voltage source, let's say a voltage source of V?
It resists some voltage.
Okay, so basically, let's name the current is equals to I here. So the I is equals to V by R, right?
V by
V by
R.
R.
So basically, a resistor obeys the Ohm's law. Anyways, even capacitor obeys it, but in some different sense. So this is how a resistor work, right? And for a capacitor, you know that capacitor, the model equation would be Q is equals to CV,
CV.
right?
Yes.
So we can't actually measure the amount of charge coming in and out. So what we do is, we know I is equals to dq by dt. You are familiar with this, right? Current is rate of change of charge. So I is equals to dq by dt. We differentiate on both sides. We get I is equals to c dv by dt, right? So
Yeah.
basically, now let's combine both the resistor and capacitor. And
Yeah.
let's say that we
I
have
think
attached a hmm.
it's RC circuit.
Yeah, it's a RC circuit. I think you are all familiar with RC circuits.
Yeah.
Okay, so I think a few of you even might be familiar with RC filters.
Yes. Low pass filter, high pass filters.
Yeah, so let's say that here we give an input voltage, V input, and let's measure our output voltage over here. Let's name this as V output. So now I would like to know what is the voltage at this particular point. So let this be Vi of t. Let this be a function of time. So basically, let's assume that the current is I of t. Now, I think you are all familiar with Kirchhoff's laws. Did they teach this Kirchhoff's laws in first 4 weeks of ESTC?
Yeah.
Okay,
In
so
second week.
okay, from Kirchhoff's voltage law, we can state that V out is equals to V in out of t minus R times I of t, right?
Yeah.
So now what is current passing through this circuit? We further sake we start using this I is equals to C dV by dt. So if we substitute that, okay, here this V means that the voltage across the capacitor. Okay, right now what is the voltage across this particular capacitor C here? So it would
Equal
be
to VT.
yeah, it would be V out, right? See, basically
Yeah.
here at this node, if you think that the voltage is V out, so the voltage across the capacitor, the other node of the capacitor, the voltage is 0. So the potential difference would be this differential. I mean, difference between these two nodal voltages, right? So basically, node is a point where 2 or 3 components meet. This is a node. I'm just saying if you don't know. So okay, if you are not getting any of these concepts, never mind. This is not going to be an electronics class. I'm just trying to give some application. So now let's replace the I with so now we got that I of t is equals to C dV out by dt, right? So
Okay.
V out is equals to V in minus RC dV out by dt, right?
Yeah.
Now if you rearrange the terms, you will get RC dV out by dt plus V out is equals to V in.
Yes.
So this is known as a differential equation. If you try finding out the solutions for the differential equation, it would be like V out is equals to that would be like V out is equals to V in into 1 minus e power minus t by RC, something of this sort.
Yes.
So
Yes.
what I'm trying to say is, see, if you look carefully at this particular equation, now let's let this equation be our prime focus. Let's forget about all this stuff. If you check out on this equation, let's check what will be the behavior of this equation uh, at various instances of time. Let's say that t is equals to 0. What would be the output? So at t is equals to 0, V out is equals to V in into 1 minus e power 1 by e power 0. That would be 0, right?
Yeah.
And at t is equals to infinity, that would be V out is equals to V in into 1 minus e power, okay, 1 by e power infinity by RC. Now here comes the problem. What would be e power infinity? So basically, we can't tell, for example, if a function f of x is equals to e power x, if they ask what is e power f of infinity, we anyways know that e power infinity is infinity, but we can't directly say that. Basically, if they say that input is infinity, we should say the output is tending to infinity. Even
Tending to
saying,
infinity.
yeah, even saying that input is infinity is wrong. Even the question should be like, if input is tending to infinity, what would be the output? Then you have to say that output is also tending to infinity. So the point I'm trying to make up here is, then here this whole term would become 0 because we know 1 by infinity is equals to 0.
Yes.
That would be is equals to V input. So basically, this is some very simple circuit, but there will be some instances where, for example, like you feel that the output of that circuit at that particular instant of time is practically not existent. But with by using some of these limits techniques and all, you come to know that it would be either infinity or tending to some other value. Basically, see now here nothing happens, but there will be some scenarios in some circuits. At some points of time, the output would tend to infinity. For example, let's connect a capacitor directly with an voltage source here. Basically, you should never connect a capacitor directly with a voltage source, but what happens when you connect a capacitor directly with voltage sources? There will be a sudden rush of current here because there is no resisting element. Like uh, capacitor produces zero resistance at the beginning of or at the initial stages, right?
Yeah.
It stores
So
some charge.
yeah, it starts to store some charge, and in the initial stages, when you ask what's the, for example, let's say that current is equals to I of t, and let's say that Q0, the
Is
initial
tending
charge
to zero.
is zero, then the current I of t would be tending to infinity, right?
Yeah. Yeah.
So basically, an uncharged capacitor will act as a short. A fully charged capacitor will act as open. So see, if there are some instances like this, for example, let's say that this capacitor is allowing a tremendous amount of current. Here we have connected this to a ground. Instead of that, if I connect to some of my appliance, let's say that some appliance, then there's a good chance that if there is an uncontrolled amount of current flowing through my appliance might, or else my gadget might blow off. So at these scenarios, when you are trying to model a particular circuit, these limits come handy. You will just try to find out some corner cases like this where there will some of the quantity tends to zero or some of the quantity tends to infinity and all. At these scenarios, uh, as you learn limits and the applications of limits, it would be useful. I guess I'm clear till now.
Yeah.
Got my point, right? So, and also, okay. So before going further, see, here we tried to find out the relationship between input and output, right? Okay, this is the equation. Okay, let's rewrite the equation. So V out by V in is equals to 1 minus e power minus t by RC. So now, for example, if let's say that V out by V in is equals to some f of x. If, for example, at some points of at some inputs, if f of x is tending to infinity, then what does it mean? See, for example, V out by V input is nothing but gain, right? So, or else you can also say that if I'm giving a certain input, how many times the output we get, or else what amplified version of the input you get as the output. If you are saying that f of x is tending to infinity at some point, then V out would be equals to V input into infinity, right? So
Yes.
basically, what does it mean?
V naught is equal to zero.
No, right? V out is also infinity. So okay, in practical sense, nothing is infinity and nothing would be actually zero. So, for example, let's say that instead of infinity in practical sense, what actually exists is some very large value. So, what does it mean is, for example, even though if your input is zero, you will still have some constant output. That's what it means. So, for example, okay, now if you properly see this, we can write V out by 1 by f of x, right? V in by 1 by f of x. If your V input is tending to 0 and 1 by f of x. As f of x is tending to infinity, 1 by f of x tends to 0. Okay, by applying some or other limits techniques, let's assume that this has some constant value. What does it mean? You are getting some output. Even though if your input is 0, you are getting some output, right? Which is an undeterministic behavior. So we use limits in order to figure out such behaviors of your circuit and eliminate such corner cases in the circuits. Yeah, most of this might be very new for you, but just remember this with due course of time as you proceed with these courses, you'll understand what I'm trying to explain now. And also, I think you have probably studied continuity and all. Let's say that you have a graph which is of this sort. At t is equal, okay, this is time axis. At t is equals to some k, your output, some output is dropping from some value a to 0. So what is happening here? Here there is some sort of discontinuity, right?
Yeah.
So okay, this is some sort of discontinuity, and let this be some other function, or else let this be x for the sake of simplicity. So this here you can see there is a sudden drop in the output, and that is happening at some instance of the input. So this kind finding this sort of discontinuities will be useful for you when you are designing some sorts of filters. You know what is a filter, right? So basically, what is a filter? There you use various kinds of filters. Filter is something which stops some undesired things. And for example, if you are filtering your tea, you use some sort of filter, right? That filter will stop all the tea leaves and give out your filtrate, which is tea. So in the same way, we have some electronic filters. If you are passing in various kinds of signals through the filters, it will allow the only desired signals into the filter and will stop the rest of the signals. Let's say that all these are my desired signals. All whichever signals rise in this range are my desired, and whichever signals lie in this range are undesired. So in such instances, we try to find out where we have a discontinuity in your particular transfer. This is known as transfer function in your particular equation. And if you are having the discontinuity at your desired value of the input, you can conclude that, okay, my filter is working fine. Okay. So these are few applications. Do you have any doubts till now? Like any general doubt is fine. Or else if you haven't understood something or you would like to know something more about this. This is more of a general session. If you also have some other doubts regarding your GS, we can also discuss those.
Yes. Okay. Please summarize once because there are lot of confusion.
Okay, any confusion which you are feeling? I mean,
Uh,
any one instance where
can
you
I
felt
say
it?
something?
Yeah, please go ahead.
Actually, you just explained this thing. These are the week 7 and week 6 content. So that's why many people don't understand these things.
Weeks in which subject? In maths?
Electronics. I'm
Oh,
saying
okay.
that.
So you are speaking about the filter design, which they explain in ESTs.
Yeah, filter designing, RC circuit. These are the all week 6 and 7 topic. That's why most of the people don't understand
Okay,
what
there's
are
no need
you
to.
actually saying. Yeah.
Okay.
Please explain us related to electronics, but in our week 4.
What you have studied till now?
You can explain like that when capacitor charge it's like show the graph of asymptotic wave. Then I think
Math related to electronics. Then we can relate it easily.
So what you have studied in first 4 weeks of ESTC? So just give the topic
Yeah.
names.
Okay, okay.
See,
Let me just interrupt here for a bit.
Sir.
So, Subhash, can we do the problem solving and see at last? Can you, those who are interested, can you just tell
Okay,
them?
sir.
That's better, I guess. Right. So let's come to the main agenda for today's session because it's already 45 minutes done. We
Mhm.
didn't get to the main thing. So it's good to start solving problems, and we'll come if you think while solving problem, if you can connect it with some electronic background, you can connect it.
Okay, sir.
yeah,
That
Okay,
way
sir.
would be right. So that would be a better to do.
these
Okay.
are
Shall we?
the very good topic to connect to the maths and electronic both.
Yes, yeah.
Okay, so shall we go with any practice assignment or graded assignment?
We will solve some tricky questions from our graded assignment from week 1 to week 4.
Okay.
Week 3.
Okay, week 3. So which question you would like me to discuss? Okay, someone was asking about question number 1 of graded assignment 3. Shall we do it?
Yes.
Okay, fine.
Okay. Before Subhash opens GA question one, see this session mainly think of it like doubt clearing session. Okay. So if I have any doubts related to week 1 to 4, just post it in the chat. So you don't have to unmute or ask anything. All right. So you just post it in the chat. Subhash or me will read the question and we will try to solve it. Okay.
Okay, sir.
Yeah. So that way it will be more clearer and more nicer. Okay. Continue, Subhash.
So okay, okay, this is the question, and let's see options one by one. So the first option is 3n power 4 plus 3n cube plus 3 by 3n power 6 plus 3n cube plus 3. So is this an decreasing sequence or increasing sequence? Uh, it's very clear that your denominator degree is high compared to the numerator degree. So you can approach this in two different ways. First of all, you can either plot your numerator and denominator, and you can see that your denominator is increasing much faster than your numerator. So you can conclude that it's a decreasing sequence. Or else you try to find the differential of the numerator and denominator separately. And then if okay, you can also find the whole differential, and if it's positive with all the inputs, then it's increasing. If it's negative, then it's decreasing.
Sorry, did I lose the connection?
What, sir?
Okay, Subhash, are you there? Just a second.
Okay.
Okay, fine. So unfortunately, Subhash will not be able to continue. So let me take over.
Okay.
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 So
Okay,
again,
sir.
so as I stated, we will do problem solving starting from week 4, I suggest. Okay, if you have any doubts in week 4, just take a look at your portal, no? Just go back. You would have done week 4. You would have stuck somewhere in some point.
Sir, please see my message.
Sorry. Okay, so I have a question in a PYQ, mainly question number 46. I'm attaching the quiz paper. So how are you getting these quiz papers? From the community, yeah? Student
Yes, sir.
community.
Yes, sir.
Great. So you yourself are making your lives difficult then. Okay. So when we know that you guys have access to these kind of things, what we will do? Any thoughts?
How so difficult? Please explain.
Sorry. Yeah. So when we know that you guys are having
Sir will not
access,
repeat the question.
we will not repeat the question. Okay. Hope my empty screen is visible.
Yes, sir.
Okay. So let me. All right. So we'll start with week 4. Okay. We'll go in order. So that way, when you come back to this session, you will also know that from 8:40 or 8:50, we started week 4. Then from 9:15 or so, we did week 3, something like that. We will have some timestamps so that you don't have to watch the whole lecture, whole session completely. Okay.
Sir, just a question about the graded assignments. The first question is the third option is actually wrong. It should be
Incorrect.
wrong.
Yeah. So that we have already discussed. Okay.
Just
Reconfirming. I understand.
So only in that question I have lost the specific mark. So will it be added
Okay.
later?
It will be added later, but it will not reflect straight away. Okay. But by the end or after quiz 1, it will be reflected. Right
Oh,
now,
okay,
team
sir.
is quite busy. Okay. So we
Okay.
will update it. We have made a note of it. We'll update it. Don't worry.
Thank you, sir.
Yeah. All right. So week 4 is all about limits of a function and continuity.
Sir, can I ask the doubt about limits, but not from this course?
Doubt from?
Doubt from limit, but not from this course.
What do you mean by not from this course?
Uh, I am from. I have a doubt in limits, but not from this course.
I understand.
My doubt includes the trigonometric function.
Okay, so trigonometric functions we introduced in week
Yeah, week
11,
11.
I guess. Yeah.
Yeah.
Okay, so if there are no doubts related to week 4, I will take your doubt. Okay.
Yeah,
So no
okay.
doubts related to week 4 within our course, I will take it first.
Sir,
Or else
practice
Okay.
question number 6 and 7.
So PA question number 6 and 7. Okay, so I'll discuss this first. So let me write it down. 3, 4, 5. So only 5 slots available. So first slot has been filled by practice assignment questions 6 and 7. Yeah, now is the time to fill the other 4. So just open portal, no? Open the portal. Just go through the contents once again. It will take not more than 2 minutes. Just scroll. Just scroll what all you have seen in week 4, the activity questions, practice assignment questions. You will know you would have faced some difficulty in one of the questions. We can have a discussion on that. No? Okay, so then we will discuss practice assignment question number 6 and 7. So question 6 and 7 is about given a function to us, f of x is equals to x plus 1 into mod x minus 4 divided by x minus 4 when x is not equals to 4, and it is k when x is equals to 4. Right? And what is given on top of it? It is given that f is right continuous. Right? So what do we mean by right continuous?
For x greater than 4 and x equal to 4, the value will be same.
Correct. Exactly true. So right continuous condition is limit x tends to 4 from the right side, right, is equals to the function value, which is f of 4. So this is what right continuous means. Left continuous, it should be the left limit should be equals to the function value. Okay, so now that we know this condition holds true, we will use this information. What is f of 4? It's k. F of 4, when x is 4, f of 4 is k. Now the only thing that is left to work out is this. How does my function f of x behave when x is to the right side of 4? That means when x is greater than 4. Right? So let us write the limit x tends to plus 4 plus. Here x is not equals to 4. X is greater than 4. Therefore, f of x behaves like x plus 1 into mod x minus 4 divided by x minus 4. So this modulus thing we have discussed in the last live session also. So when x is coming from the right side, or when x is greater than 4 and coming towards 4, what will be the values of x minus 4 be? Will it be positive or negative? So this one. X is greater
It
than
will
4.
remain x minus 4.
This is positive, right? Whatever the thing inside the modulus is positive. So if it is positive, modulus doesn't play any role, right? So whatever there inside the modulus, it will be as it is. So if you write that, this will become limit x tends to 4 plus x plus 1 into mod x minus 4 will just simply become x minus 4 divided by x minus 4. Now this and this will get cancelled out. We will be remained with x plus 1 and x is approaching 4. So when x approaches 4, x plus 1 is just a straight line. It is continuous. So what will the value be? 4 plus 1, which is 5. So the left side is equals to 5 and the right side is k. So from these two, what can we conclude? We can conclude that k is equals to 5 because it is right continuous. Right? So this is sixth problem. Is this okay? Any doubts here?
Okay, sir.
Okay, yeah. So now coming to question number 7.
Yes, sir. One doubt, sir.
Yeah.
How you wrote that line? F is right continuous.
It is given in the question.
Oh, okay, sir. Okay, okay.
This is given.
Okay, sir. Okay, got it.
Yeah. All
Sir,
right.
in the question, if we reach a point where it comes to like infinity by infinity, so should we take it as 1?
No.
Okay, sir.
So if you reach infinity by infinity forms within week 4, the only thing that you should do is you should try to simplify this. So there are many ways.
Sir, like it's like if it's like x by x and x tends to infinity, should I just do x by x and get 1?
Correct.
Okay, sir.
So you have
That was
to
good.
cancel the terms like numerator
Yes, sir.
and denominator has same factor. Okay. At least till week 4, if you are encountering infinity by infinity, then definitely your numerator and denominator has some common term, common factor, which can be cancelled out.
Okay.
So
sir.
cancel it out and then you will simplify. Okay.
Yes, sir.
And
yes.
in week 6, we will learn one beautiful rule, which is called L'Hopital rule, one application of derivative. Okay. So then once you know that, you can use that rule also. Okay. So we'll see these things in week 6. Okay. So in 7th problem, what they gave is they have given values for k. So k is given some values. In some options, it is given -5. In one option, it is given 0. Okay. So, and they were asking limit of the function will exist or not, whether the function is continuous or not, whether it is left continuous or not. Okay. So as I said in the previous live session also, so the most important thing from week 4, which you should definitely develop is try plotting the curve or the function. So try plotting the function. So if I simplify this f of x further, just by removing this modulus, so I will have more pieces, but the function looks much easier. So what happens when x is less than 4? How does this function behave? When x is less than 4, anybody? When x is less than 4, this is how function behaves. Also, when x is less than 4, here this term is negative. So modulus of a negative term will become
Negative.
minus of it. So the
4 minus.
modulus, yeah, so this will become 4 minus x. So 4 minus x divided by, so this will become 4 minus x. 4 minus x divided by x minus 4, overall this term will become -1. Right? When x is less than 4, this will become -1. So -1 into x plus 1 is minus x minus 1. Is this okay, all of you?
Yes, sir.
So x is equals to 4, you can write it as k. When x greater than 4, just now we saw. So when x is greater than 4, this and this will just simply cancel out and only x plus 1 will remain. So if you try to plot this, what will you get? So let me take this down. This is our f of x now. And we are roughly plotting. We are not exactly plotting it, but we can roughly plot this. Right? So this is x. This is f of x. Now you see when x is equals to 4 is the critical point for us. So let's mark this as 4. Okay. So when x is greater than 4, it behaves like x plus 1, which is a straight line. with positive slope, right? So I know how to plot straight lines. It will just be like this. What is this point? What is this point? When x is equals to 4.
5. 5, sir.
So this is 5. But you observe
Yes, sir.
that this is x greater than 4. At x is equals to 4, we didn't define yet. At x is equals to 4, it is just right. At x is equals to 4, we don't have x greater than 4, it behaves like x plus 1. But this is 5. Next, when x is less than 4, it behaves like minus x minus 1. Now, how does minus x minus 1 will behave?
Negative.
Now, you just substitute 4 and see, no? What are you going to get? So, what are the critical points that we can observe? At 4, it takes minus 5. At 0, at x is equals to 0, it should take minus 1. So, that means this is the line should pass from this point. At when will y become 0? When x becomes minus 1, minus 1 of minus, it will become 0. So, something like this, right? So, this is how it will be. And this point is minus 5. Right? So, and there is some k. So, at 4, k can be anything on starting from plus infinite to minus infinite. It can be anywhere. So, k, if k is equals to 5, then it becomes right continuous. Right? If k is equals to 0, then it will not be continuous at any point. It will not be right continuous, it will not be left continuous. Right? Definitely limit will not exist because the left limit will never be equals to right limit for any value of k. Correct? So that way you can exclude option B straight away. Limit of the function will never exist for any k value because as you can see the left limit and the right limit are both are different. So the left limit is minus 5 and the right limit is 5. So straight away limit will not exist. Therefore it will not be continuous also. So option A, B, D, everything will be ruled out. And option C says when k is minus 5, the function f is left continuous at x is equals to 4. And that also you can easily see from the graph. That when k is equals to minus 5, that means the function value is exactly equals to the left limit. Therefore, the function will be left continuous. Okay. So if you plot, it is easier in this way. If you didn't plot, then what you have to do is you have to go by option by option. You take option A. What does option A says? K is equals to, if k is equals to minus 5, then the limit of the function f exists at x is equals to 4. So what is the condition for limit existence? You have to check that 4 minus of f of x, whether this is equals to question mark, whether this is equals to the right continuous or not at k is equals to minus 5. Okay, so this you have to check. Once after that, then move to the option B. Again the same thing, you will check the same thing at k is equals to 0. Okay, and then you will observe that actually for checking limit existence, you don't actually need the value of k. Only the left and right limits are sufficient. and then you move to option C and check left continuity, which is limit x tends to 4 minus f of x is being equal to f of 4 or not at k is equals to -5. Okay, and similarly you will check whether your left limit, your right limit is being equals to f of 4 at k is equals to -5 or not to conclude the continuity. So you have to follow a long lengthy process. Okay, so this kills each option kills you some more than 1 minute time, right? Once you have this plot, a rough plot in the mind, it will not take more than a minute to choose the correct answer, right? So this is how you should solve this particular problem. Okay, so if any other doubts in week 4?
Sir, question 4. PA.
PA, practice assignment.
Yes, sir. Question 4.
Okay, question 4 is about the graph is given to us, right?
Yes, sir.
Okay. Which option exactly? From the graph you can directly decide, right? So that solid dots represent the function will take the value at that point, and the hollow dots represent that the function will not take that point. So any specific option or every option you want?
Sir, option 3 and 4.
Okay, left limit and the right limit at 4, right?
Yes, sir.
Okay, so let me take the image. Okay, so okay, I think it will appear soon. Okay, so this is the graph, right? And at 4, you want to find the left limit of this function and the right limit of this function. You see from the graph, what does left limit mean? You are starting from left side of 4 and you are moving towards 4, and you are observing how is the function
Rishabh,
value changing. Can you mute?
can you mute?
Yeah. I will answer your doubt. Can you mute, please?
Rishabh, can you mute?
Okay, I have muted. All right. So always think of it in this way. Okay, so left limit, if you want to find the left limit given the graph, if you want to find the left limit, imagine that you are left side of 4 and you are coming towards 4 and you are monitoring the function values, how the function values are behaving. So if you are here, your function value is here, and if you start moving towards 4 this side, your function values will start from here and slowly start moving upwards, because your graph is like that, right? It will slowly start approaching this value, this point. By the time you are reaching 4, you will not see, that is what limit means. You will not go at 4, you will go towards 4. Even after infinity time also, you will still be reaching 4. So it's like, imagine that you are in a dream and you are chasing something and it feels like you are very close to it, but you will never reach it. Okay, it's like that. So if it is like that, the function values also will start approaching this point, but it will never reach that point. As a limit, what we say is it will reach and it will take that value. That is what the limit value means, right? So if that is the case, the left limit of this function at 4 will be this. What is this value? This is 10. Similarly, the right limit is, now you should imagine that you are on the right side of 4 and you are going towards 4 and you monitor the function values. So if you are here, the function value is this. And if you move to the left towards 4, then the function values will go and slowly start approaching this point. Right? So what is that point? That point is 4. So the right limit will be 4. So from the graphs, it is very easy to get the left limit, right limit and all. And also it is very easy to conclude whether the limit is existing or not. So if you don't see that both are coming towards the same point, then limit will not exist. Right? And also continuity is very, very easy to understand. If there is a break in the graph, just like at point 2 and point 4, so there is a sudden break, right? Like sudden jump. So that itself says that you cannot draw this curve without lifting your pen, right? So you can start drawing like this, and after reaching this, you can't go to this point unless you lift your pen. So whenever you are lifting your pen, it implies that it is not continuous.
Sir, one question. Like at 4, for the left hand side, it is indicated by a hollow point. Hollow. That means that particular yeah, the function does not take that particular value at that. So, will the limit exist? As a left hand side limit will exist at that point?
Left hand limit will exist. Limit will exist, but the function value at 4 will be 4,
right,
which is denoted by the solid point.
Okay.
Okay. Anything left of 4, there is a sudden jump. So you directly jump from this point to here.
Right.
Okay.
Okay.
So that is what this means.
Okay.
Okay.
Sir, but VR graph consider the sharp corner or a sharp turn, then not continuous.
That is continuous, but it is not differentiable. That we will see in week 5.
Okay.
Yeah. So sharpness is another property of the curve, which we term it as differentiability. Okay. So
Yes,
continuity represents the connectivity of the curve. So whether it is completely connected or is there any breaks. Differentiability is like smoothness of the curve, that we will see in week 5. Okay. All right.
Sir, in graded assignment 4, there was a line like F is right continuous, F is left continuous. So left hand limit and right hand limit is understandable, but what is right continuous and left continuous?
Okay, just now we discussed, right? So right continuous means your right limit is equals to the function value.
Okay, sir, got it.
Left continuous is your left limit is equals to the function value.
Okay, sir.
Okay. Yeah. So here at 4, what do you think? Is it right continuous or left continuous? At x is equals to 4.
So right continuous.
Right continuous. Because the right limit is exactly equals to the function value. Right? Tends to 4 plus f of x is actually equals to f of 4, which is both are equals to 4. Right? So that is right continuous and left continuous. All right. Any other doubts in week 4? Okay. So let's move to week 3. So week 3 is all about sequences. Right. So we started discussing sequences. What is a sequence? And then we talked about different properties or classifications of sequences, like bounded, above, bounded below, and completely bounded unbounded. And then we also talked about increasing, decreasing, right? And then within this bounded above, bounded below itself, we also talked about lower bound, upper bound. And then we talked about limit of sequence, right? And finally, limit existence of a sequence, like what kind of sequences will have limit. And we talked about MCT, which is monotone convergence theorem, right? So this is all we discussed. Sequences and examples also, like how different ways of defining sequences, giving the nth term or giving the recurrence relation. So all those comes under sequences, right? So now I will just open it for doubts.
Sir, question 8 PA.
Week 3.
Yes, sir. Sir, option B and C.
Question 8. All right.
Sir,
Hmm.
can I leave? My Linux class already started.
How can that start? What is that?
Linux.
Is this scheduled every week?
Yes,
Yeah.
Sir, I think the Linux classes, the TA classes are not compulsory.
Okay, it's a TA class. Okay. So if you want to attend,
No,
you
no,
can.
no. It's compulsory for all students, sir.
No, we
I
don't
got
get
a mail.
we
I got a mail.
at least we for electronics ones we don't get an mail saying that the TA session is compulsory. The instructor sessions which are held, they are we get a mail saying that they are mandatory and compulsory. But for TA sessions, at least I haven't got an email saying that.
Okay, so let me clear that. So
I
TA
also
sessions
have
are
not
not
get any mail.
mandatorily. Sorry. TA sessions are not mandatory to attend, but if you have doubts there, I suggest you to go attend that session.
Okay, sir.
Okay. Yeah.
Okay.
All right. So let's continue. So question 1, 2, again I will give you guys 5 options, 5 questions. So the first one is PA question number 8. Anyone? From week 3.
GA question number 7.
GA question number 7. Okay. So 3 more slots available. GA week 3 question 1, Vishal, I just said, right? Like I have discussed the replica of it in the Solve with Us session. You can take a look at it, but there is an issue with week 3 question 1. We will update it. Okay, so option C is not decreasing or increasing. There is something wrong in that. Okay.
Sir, question 7 and 8 also, sir.
Question 7 and 8 in which?
Week 3, GA.
GA. Question 7 you already said.
Yes.
Question 8. Okay. So 2 more slots available.
So, question 9 also.
GA.
Yes, sir.
Okay. Last one. Anybody? If you're not willing to unmute, you can just type it in the chat also. That won't be visible on YouTube.
Sir, activity 3.6, question number 1.
All right. Okay. So we'll do these 5 first and then we'll see. Let me. Yeah. Question number 8. We have given 4 options. You wanted option B and C, is it?
Yes, sir.
Okay. So option B says that AN is an increasing sequence. Right? So what does that mean? That is also given in the statement itself. It means that all your current terms are lesser than or equals to the next term. Right? Your A1 is lesser than or equals to A2. Your A2 will be lesser than or equals to A3. Every next term in your sequence will be either greater or it will stay the same value. So that is what this means. So for all I belongs to natural number set. Now what the statement says is this is the if. So if this is true, then minus 1 an is a decreasing sequence. Okay, so what do you guys think? So in order to prove these kind of things, see we have what we have to prove. We have to prove either this is decreasing or not. Right? For decreasing sequence, what is the condition? Your next term should always be lesser than your current
previous
term, or it should stay the same value. That is, all your AIs should be greater than or equals to AI plus 1. Right? Or if you are confused with A everywhere, think of this as a new sequence Bn now. Okay, you think Bn is your minus 1 of An. Okay, so now how are the terms will be in this sequence?
Sir,
What is your B1, B2, B3?
intuitively this seems to be true because
Yeah.
if you have 1 2 3 4 and then you say minus 1 minus 2 minus 3, then the sequence the numbers will go on, it will be a decreasing sequence.
Correct. That is what it is. Prove intuitively it is true, and also if you prove also you will get the same. So here your sequence is B1, B2, B3 and so on. What are B1, B2, B3 in terms of A1, A2, A3? They are just simply minus A1, minus A2, minus A3 and so on. All you need to prove is whether your minus A1 is greater than or equals to minus A2, is greater than or equals to minus A3 and so on or not. Is this true? If you multiply throughout minus 1, what will you get? A1 less than or equals to A2 less than or equals to A3 less than or equals to A4 and so on. And what is this? This is basically the same thing, right? You know that this is increasing, it is given. So that means this is true. Minus, if you multiply just the minus, then this will be true. If this is true, then this particular sequence is actually a decreasing sequence. That's it. Is this okay? So if you have an increasing sequence and you just multiply minus 1 to every term in your sequence, it will become decreasing. Right? Intuitively also it is true, right? From the stem plots also. So you know how the stem plots work. Right? So graphically also makes sense. So this is how, if you plot the stem plot, always either the next stem should be great, will have more height or the same height, right? Something like this. And so on. If you take minus of this, what will happen? It will come in the denominator, come below x-axis, right? So this is how it will be. What are these? So this is negative small, something small negative value, slightly larger negative value, which is lesser than this value, right? So this is decreasing. If this is increasing, this will decrease. So this is an, this will be minus 1 times an. That's it. Graphically also it makes sense. So you just need to understand the statement and you should be able to prove it in one or the other way. So this is like writing in math terms and proving it. And this is the graphical way of or intuitive way of understanding the statement is true. Okay, I hope that is clear. Option C states AN and BN are convergent. Then, so if this is if, then A and BN must be convergent. So what are convergent sequences? So what are convergent sequences?
Sir, as the sequence tends to infinity, it will come to a specific value.
Which is nothing but limit exists.
The limit exists.
Yeah. So if AN is convergent, then limit n tends to infinite, AN takes a value L. And similarly, if Bn is convergent, limit n tends to infinite, Bn will tend to, if this is going to L1, this will go to some other value L2. So this is given. What they are saying is, what will happen to this limit, An times Bn, as n tends to infinite? Will it go to a real number or not? Will it go to infinite? What do you think will happen? Come on, it is just the property of limits that you have studied in week 3. No? Just think, no? What is happening here? What will happen to this limit, product limit?
So convergent means
Limit should exist. The sequence has a limit. So if the sequence has a limit value, then it is convergent. So if AN is convergent, we will have a limit value. BN is convergent, we will have a limit value. What will happen to this limit?
So, sir, it will be sir real number.
And that real number will be equals to, tell me in terms of
L1
L1
into L2.
L1 into L2. Yes, sir.
So this will become L1 into L2. And you know L1 is a real number, L2 is a real number. Product of two real numbers is a
real number.
Real number.
Real number. So once this is real number, that means limit exists. If limit exists, then this sequence must be convergent.
Yes, sir.
That's it. That is what option C is. Okay. So this is clear.
Okay, thank
So,
you, sir.
Yeah. So GA 7, 8, 9. Let me see what those are. Okay, so 7, I think we have discussed this already in detail.
We did a similar question.
Similar
also.
kind of question.
Instead of 0.1, we did with 0.2.
0.2, that's it. So I suggest you to go back to the solve with us session of week, the last Tuesday session. Okay, so GA7.
Okay, sir. Okay, I missed the last session.
Similar kind of question. Did in previous live session. Not previous live session, it is. We did some live. Did in last Tuesday's live session. Okay, I suggest you go back and do it there. Eighth one is a bit interesting. but it's not that difficult also. If you see, given a series like this, 1 square plus 2 into 2 square plus 3 square plus 2 into 4 square plus 5 square plus, just stare at the, you should just stare at the series, how the series is designed. Okay. So if you take the first two terms, like even terms of the sequence, how are they looking? So you have 1 square plus 2 times of 2 square. Similarly, if you see 4 terms together, okay, it has 1 square and 3 square in it, and 2 times 2 square and 2 times 4 square in it, right? So 2 of this kind and 2 of this kind. So if you pick even terms, so you'll always have 2 of this kind, or the number of terms of this kind will be equals to the number of terms of this kind, right? But when you pick the odd number of terms, you will see that 1 square or these first three terms or first 5 terms, you will see that this 1 square, 3 square, 5 square, if it appears 3 times, you will see only two terms like this. Now what does Sn represents? Sn is the sum of first n terms.
Sir, but actually, at first I was thinking it as 2.2 and 2.4 like that. I did not.
Oh, it's not 2.2. Actually, it is 2 into 2 square.
I later understood it, sir. But
okay,
at starting that was a mistake I did.
Okay. So it looks like 2.2 whole square, but when we say whole 2.2 whole square, we will be having this brackets, no?
Okay, sir.
So that's the difference between the product and point. So if we had said 2.2 whole square, it would have been some brackets coming into the picture. Okay, so Sn being the first n terms in the series, as of now I discussed, right? So if you take, if n is even, then you will have this kind and this kind equal number of terms. When n is odd, you will have this kind one more than this kind. And also what is given is, when n is even, Sn is given to you. Sn is simply n into n plus 1 whole square by 2. Right? So that means if you pick n terms where n is even, the sum actually equals to n into n plus 1 whole square by 2. So here n is even. So that means n, sorry? Did anybody ask any question here? Okay. So what they asked is, when n is odd, how will Sn look? Right. So what happens when n is 1, 3, 5, 7, 9, and so on. Right. So this kind, if we give you options, you can do one easiest way, which most of us will do. Even I did in my childhood. So can anybody point out what is the easiest?
Substituting.
Substitute. Correct. Just substitute n is equals to 1, 3, 5. And you can find the option easily. But if you have to prove mathematically, this is how proof goes. So we know when n is even, this is how it looks. Right? When n is odd, what will happen? You have even number of terms and you add one more term to it. It will become overall, it will become, so you will have even number of terms. By adding just one more term to this, right, it will become overall, it will become odd number of terms.
Yes, sir.
Right? So that is what you have to use here. So as we said, Sn for even, when n is even, So let's take that n even, and n plus 1th term is the odd one. Okay. So it will look like 1 square plus 2 into 2 square plus 3 into 3 square plus and so on. Since n is 3 square plus 2 into 4 square. As n is even, we know that. So this will be 2 into n square. So this is Sn. Right. So this is Sn. We need sum for odd number of terms when n is odd. So what will be the next term? It will just simply be n plus 1 whole square. Correct. So this sum is given to you, n into n plus 1 whole square by 2. You just have to add n plus 1 whole square to it. Right. So n plus 1 whole square by 2 plus n plus 1 whole square. What are we getting? Are we doing? Oh my god. Okay. Sorry. Okay, so this when n is even, this we have. When n is odd, how does this Sn will look? This is how it looks: 1 square plus 2 into 2 square plus 3 square plus 2 into 4 square and so on, plus 2 into n minus 1 whole square plus n square. Right? So here n is odd. So n is odd here. Okay. So when n is odd, your nth term should be your odd term. Okay. So when your nth term should be odd term. Odd terms are always of this particular form. Okay. And you know this summation. Right. So this is like even number of terms with n minus 1 terms. Instead of Sn, you have to compute Sn minus 1 for even case. So this is even number of terms when your n is actually n minus 1. So you can think of it like k. So your Sk is like k into k plus 1 whole square by 2. So where k is even. Okay. So here that k is basically n minus 1 because you have n minus 1 term, n minus 1 even terms. Right. So substitute k is equals to n minus 1. You will get Sn minus 1 as n minus 1 into n square divided by 2. Now you are adding n square to this. If you add n square, then this will just become n minus 1 into n square plus 2n square divided by 2. Right. So when you add n square, it will just become Sn. So this will just be n cube minus n square plus 2n square by 2. This will be n cube plus n square by 2. You pull out n square common, this will just become n square into n plus 1 by 2. Okay. So all we did is we wrote Sn when n is odd. Okay. So this you can write it just by writing S1. You write S1 once, S3 once, and S5 once, and you will start observing a pattern. Then you can write Sn when n is odd. So this is how it looks. But you know the summation till here because you know the summations of when n, or if you consider only the even number of terms, you know what the sum will be. Right? The sum will be of this form, where you just have to substitute in place of k, you just have to substitute n minus 1. If you do that and add the nth term, so one more term, this will become sum for n terms. So that is what I did. So if you simplify it, you will get this. Okay.
Okay, sir.
Yeah. And okay, question 9. is statements given to us, and you just have to form a recurrence relation, right? So it is said that the front row consists of 5 people, and each subsequent row has one less than twice the number of people in the row in the front of it. Okay. So let's take this as the front row. And there are 5 people. Right? Sitting in the front row. And how does this next row? Next row has one less than twice the number of people in the row in the front of it. So in the front row, there are 5 people. So twice the 5 people are 10 people minus 1, which is 9. So there are 9. There will be 9 people in the second row. Right? So that's how you should interpret it. So this is the twice number of people in the front row, but there isn't twice the number. It is one less than twice the number of people. So one person should be erased. So the total will be 9 people in the second row. Similarly, in the third row, again, in the third row, how many people are there in the front? There are 9 people. So if there are 9 people in the third row, there will be twice the 9 people minus 1. Right? So something like that. So
17 peoples.
17 people. But if you have to write in the recurrence relation, your nth row will consist of twice the number of people in the n minus 1th row minus 1. And your first row contains 5 people. This is the recurrence relation. Okay. So that is GA 7, 8, 9. And AQ 3.6 question 1.
Okay, sir.
Okay, so AQ 3.6 question 1. Is about your AN is given to us. Okay, and we are asked you to compute limit as n tends to infinity AN. So there is a shortcut for these kind of expressions. Okay, so
just consider the coefficients of the
highest
variable
powers.
with the highest power.
Correct. Very good. So if your numerator and denominator has the same powers, okay, the same highest power. So here highest power in the numerator is 2. Your denominator also has the highest power as 2. So the shortcut is very simple. So you consider the coefficients of the highest power in the numerator and denominator. So in the numerator, the coefficient for the highest power is 3. And in the denominator, the coefficient for the highest power is 6, which is half. Okay. You can also do this using the limits, where what you have to do is you take the same expression but modify it a little bit. So you pull out n square common from the numerator. You will have 3 plus 5 by n plus 2 by n square divided by, you pull out n square common from the denominator also. You will have 6 plus 2 by n plus 1 by n square. And now you cancel this n square and n square. As n tends to infinite, 1 by n will go to 0. So these terms will, 1 by n square also will go to 0. So these terms will go to 0. And finally, again here also you will be left with 3 by 6, which is half. For example, another example is, if your an is something like this, 4n square plus 5n divided by 6n cube plus 2n square plus 1. something like this. Okay. So now your denominator has highest power is greater than your numerator highest power. In such cases, as limit n tends to infinite, an will go to 0. Okay, so this also you can prove analytically. So pull out n square common from the numerator, n square common from the denominator. You cancel out those n square and n square. But you still have n term sitting inside the denominator. Right, as n tends to infinite, the denominator will blow up. And when the denominator is very large, and the numerator is just a constant, approaching a constant, so overall the numerator divided by denominator will go to 0. And the other case, when your an, where you have more powers, highest power, highest degree in the numerator is greater than the denominator, then what happens? Then limit n tends to infinite, an will go to infinite. Okay, so it depends on the dominating term. Okay, so these are the only three possible cases. Either the highest degree in the numerator and denominator are the same, or your numerator will have greater degree, or your denominator will have the greater degree. In all the cases, this is how you should solve the problems. So case 2 and case 3 are very easy. So if you see highest power in the denominator, straight away 0. If you see highest power in the numerator, straight away it will be plus infinite or minus infinite depending upon the coefficient. So if your coefficient is positive, it will go to plus infinite. If your coefficient of the highest power is negative, it will go to the minus infinite. Okay. So that is the only carefulness you have to take care. Whereas when your numerator and denominator has the same powers, highest powers, then just take the coefficients of the highest powers and just do the division between them. That will give you the limit. Okay. All right. So that's about week 3. Week 2 and week 1 we will do in the revision sessions. Okay. So do not. So at least week 1, I hope you all know all the contents. You are much familiar with those. Week 2, there are 2-3 problems where again some sort of support is needed that we will do during the revision session. Okay.
Sir, when the revision session happen?
Next week after week 5's deadline. Wednesday and Friday we will have 2 revision sessions.
Okay, sir.
Okay, then it's 9:53. We can, if there are no doubts related to week 3 and week 4, we can end the session here. Okay, so we will meet on Friday, and on Friday we are going to do, or we will be doing week 5. Okay, so we'll start week 5. All right, then we'll stop here. Thanks all for joining.